So a unit circle is basically a circle whose center is at the origin and that it has a radius of 1 unit. Okay? All right, so that's fine. However, all of these triangles and stuff that we've been drawing, right? Like the special right triangles. So for example, if you look at the 30, 60, 90 degree triangle, right, that we've been drawing for our, trig values, they have sides of 1, root 3. No. And 2. Oh my gosh. I went ahead of it. Okay, so 1 root 3 and 2. Okay, so that's fine. So now, if I'm working in this circle, though, if I take that triangle, it won't fit in that unit circle, right? It's gonna be way too big if I try to fit that into this unit circle, right? That means what I would have to do, right, then, is I'm gonna take this and just kind of like drag it down and like resize this a little bit, right? So you know how like when you resize a picture proportionally, each part, of that picture gets resized by the same amount, right? So in order to make this hypotenuse fit here, right? The radius here is 1. In order for this hypotenuse to become a 1, what should I divide it by? What do you guys think? Divided by 2, which means all the other sides should also be divided by 2 in order for me to get a triangle, right, that now has a hypotenuse of 1 and it could snugly fit into my unit circle. Do you guys get the idea behind this? So what we have to do then is we have to rescale those special triangles. But it's okay because, they were special to begin with. And when you rescale them, they become like even more special. And like that's the version of them that we absolutely love. So we were saying like whatever that side is, this is root 3 times that, and this is 2. And so now we just divide everything by 2. So this side becomes a 1. This side becomes a half, and this side becomes root 3 over 2. Same thing with the 45, 45, 90. With these two sides are equal to each other. So if I make them have a length of 1, the hypotenuse will have a length of root 2. So what should I divide it by in order for it to be a length of 1? Root 2. Divide this by root 2, divide that by root 2, and of course I'll rationalize them so it becomes root 2 over 2. Okay, fine. So let me just get rid of this for a minute, and let's just ask ourselves, okay, it just seems like a lot of theatrics, right? And it's like, what have we done really, right? Well, let's think about what we've done. You remember good old SOHCAHTOA? You remember that? How did we do this? It was always, okay, the opposite side over the hypotenuse, the adjacent side over the hypotenuse. But now, if the hypotenuse is 1, and if I do opposite over hypotenuse, I'm just going to get the same number back, right? If the hypotenuse is 1, I don't ever have to divide by that. That means I can literally just drop the h's from here because the hypotenuse is always 1. And so SOHCAHTOA just becomes sine is the opposite side, period. Cosine is the adjacent side, done. And then tangent is just opposite over adjacent, right? So if I take a look at this right now, sine of 30 degrees, just the opposite. I don't need to divide by that 1 anymore. It's silly now, right? Cosine of 30, just root 3 over 2. It becomes so much more efficient, okay? All right, so let's go ahead and place a rescaled triangle inside the unit circle, all right? So here is our 30, 60, 90 triangle inside the unit circle with the 30-degree angle here as the reference angle. So what are the sides of this triangle? Well, this is the short side. It's automatically a half. This is the long side. It's root 3 over 2. So remember, for the 30, 60, 90 triangle now, we only have two sizes left, right? They're dropping like flies, let me tell you, right? So we have a half and a root 3 over 2, the short one and the long one. So we do this here. That means, right, what we're doing with this trig business is always, when you have an angle of 30 degrees and you've got that terminal side, the question is always, at what point does that terminal side intercept the unit circle? So this is the terminal side. In a unit circle, this is a length of 1 along the hypotenuse. At what coordinate point does it hit the unit circle? In other words, how do I get to this dot? Well, I have to go over a space of root 3 over 2 and up a length of half. So what are the coordinates there? Root 3 over 2 and a half. So now, okay, what is the cosine of 30 then? Just root 3 over 2. And what is the sine of 30? 1/2. Okay, so can we come up with any conjectures here as far as the coordinates of these are concerned? What are these coordinates? Where do they come from? Yeah. What is the x-coordinate, for example? Right, the x-coordinate here is the cosine of 30. The y-coordinate is the sine of 30. And if you remember, I started telling you this last time, right, last week, where I said always associate, right, sine with the vertical side or the y value, cosine with the horizontal side or the x value, right? And the sooner we associate cosine with the x value, y with the sine value, things just become so much simpler, okay? So much more efficient. Okay, so this is the big idea. Each point on the unit circle has the form x comma y, which is cosine comma sine. So, now, here is the unit circle, okay? And I kind of always hesitate doing this because here is what I never want you guys to do. I never want you to blindly, there are like all these like mnemonics out there. Oh, you just like put 1, 2, 3, 1, 2, 3, blah, 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 blah. Never, ever, ever do that because that does not show understanding, right? I always say, if I have like, okay, now my kids are getting older, but like I always used to say, like when one of them was 5 or something, if I teach my 5-year-old to memorize this, have they learned any trig? No, like if a 5-year-old memorizes the circle, they don't know any trig. So that's not what we want to do. However, if this is the 30-degree angle, the radian equivalent is pi over 6. So now, how do I get to this point, right? Well, to get to this point, I have to go longer horizontally and shorter vertically. Is that right? That means longer horizontally, shorter vertically. Now let's do the 60 here, which is pi over 3. To get to that point, I have to go shorter horizontally, longer vertically. So shorter horizontally, longer vertically. All right? Now let's do 30 and 60 on the opposite side. So this is going to be 150 and 5 pi over 6. To get to that point, longer horizontally, shorter vertically. So I have to go negative root 3 over 2, positive a half. For the 60 degree here, it's 120 degrees and 2 pi over 3. Do I go shorter horizontally or longer? Shorter horizontally, so it's going to be negative a half root 3 over 2. Okay? So now let's go down here. This is the 30-degree equivalent here. What's the degree? How many degrees? 210. And what is it in radian?
7 pi over 6.
Yes. So to go here, right, this is the triangle. I have to go longer horizontally, negative root 3 over 2, down shorter. Negative root 3 over 2, negative 1/2. This is the understanding I want you guys to have. Why? Because in honors, it's not about the answers, it's about the understanding. And I can't say this enough. I'm from your future. I'm coming from where you're going, right? So this is what you're going to need over there. So here, this is how much now? 330 or 11 pi over 6. Go longer horizontally, positive root 3 over 2, down negative 1/2. Isn't that cute when you do it that way? It's so much cuter than like anything else. Yes?
What's the radian for 60 in the third quadrant? Is it 4?
That's a good question. That's the one we're going to do next, wouldn't you know? 60 in the third quadrant is here, 240 degrees. How much is it? Not like, exactly 4 pi over 3. 5 pi over 3 is the next one. So to go here, I go shorter horizontally, longer vertically. So negative 1/2, negative root 3 over 2. Okay, that means, let's pause here for a minute. If I were to ask you for the cosine of 240, you're like, okay, 240 is here, right? That's a 60-degree angle. So I go shorter horizontally, that means it's going to be the 1/2. Negative 1/2 is going to be the cosine. And the longer version, root 3 over 2, is going to be the sine. Okay? So cosine and sine. Let's do this next one, 300, which is, this is the 5 pi over 3. Okay? So take a look. This is the triangle here. Okay? So to get here, right, what's the cosine? That's the x value. That's the shorter one on the x, and the longer one on the y, which is the sine. So cosine is 1/2, sine is negative root 3 over 2. Okay? Cosine is 1/2, negative root 3 over 2. Okay. The 45s, we love the 45 degrees. They're kind of boring because you go equally right and up or left and, vertically and horizontally. So to go to the 45 degrees, this is pi over 4. It's going to be an equal distance horizontally as it would be vertically. So it's root 2 over 2, root 2 over 2. So cosine is root 2 over 2, and so is the sine. For the other one, 135 degrees, 3 pi over 4. Again, I go root 2, but this time I go to the left. That's the plot twist. So negative root 2, positive root 2. Over 2, I mean. And then here, this is the 225, 5 pi over 4. What's that going to be? Right. And finally, 315, 7 pi over 4, positive root 2 over 2, negative root 2 over 2. Bless you. Huh? Yeah.
I had a revelation.
Love to hear that. Yes. Yes. Okay, good. Once the revelation happens, there is like, it's like that sweet spot. Okay, so now let's do the quadrantal angles. All right, let's do the quadrantal angles here. So now we know that this radius is 1. So if I'm here, which is 0 degrees and 0 radian, how much do I go horizontally to get to this point? How much do I go horizontally? 1. How much do I go vertically? Okay, that means cosine is 1, sine is 0. And it's easy because it's in alphabetical order. Cosine comes first, then sine. Okay? Cosine, sine. Here I have 90 and pi over 2. How do I go over there? How much do I go horizontally to get to 90 degrees? 0 horizontally. How much vertically? 1. So if I ask you or if somebody asks me what's sine of pi over 2, you'll always see me doing like this. Oh, sine of pi over 2, that's 1, because it's up here. okay? Pi 180, what's the cosine? -1, and the sine is 0. 3 pi over 2 and 270. Okay, switching it up, what's the sine? What's the sine then? -1 is the sine, and the cosine is 0. I went in opposite order this time. And then, of course, like 360 and 2 pi, we go back here, and look at that. This is the unit circle. It's every math teacher's favorite thing on the planet, like for real. Yes? Okay. All right. Okay. So let's go here. Okay, that was exciting. I always love doing that. Suppose the terminal side of an angle intersects the unit circle at the given points. Find the values of cosine and sine for each angle. So this one is the cosine, right? Right, and what's the sine? 1/2. So then it says, find the measure of the angle in radians and degrees, referring to the unit circle. So basically, let's see if we can do this kind of blindly. I'm going to go over positive √3/2 and up 1/2. How many degrees is that going to be? 30 degrees, which is pi over 6. Okay? Okay. So here, 0 and 1. How much is the cosine? And the sine? -1. So the angle then, so let's think about this. I go 0 horizontally, -1 vertically. 3 pi over 2 or 270. Good.
How are you getting that from 0
So because, let's go back here, we kind of did, I was trying to like visualize, but let's say, you know, that's not happening. Draw yourself a cute little unit circle, right? And you say, okay, x is 0, y is -1. That means I'm right here, right? And that corresponds to 3 pi over 2 or 270 degrees.
Can you do that?
And this one, yeah. So this one, again, unit circle. We start from the origin. I go to the right, √3/2. Whoops, hang on.
What does that mean you go to the right √3/2?
So this is 1, okay? That's like x equals 1. √3/2 is less than 1. It's like 0.8 something. So from the origin, I go to the right √3/2 spaces, and I go up 1/2. Here, I go over √3/2, and I go up 1/2, so it corresponds to that coordinate. Okay?
So
Yeah.
cosine always be x.
Always.
Sine is y.
Always. Always, no matter what month it is, if it's in the US, in Paris, even in the southern hemisphere.
Is there tangent?
Tangent is always going to be y over x.
Oh, okay.
Mm-hmm.
This
Okay.
is but I don't get still like how you get pi over 6.
What angle, okay, so if the x coordinate is √3/2 and the y coordinate is 1/2. So now look, you created a triangle with a side √3/2 and 1/2. What angle does that correspond to? That's the 30 degrees, right? Because like if you go back to these triangles, that corresponds to the 30 degrees, right? 1/2 √3/2 and 1. Okay? All right. So here, let's find the exact value. All right. Sine of 135. Okay? So if you like, refer to your unit circle, right? Sine of 135 here. Now, on a quiz or a test, you're not going to have a unit circle, okay? So, like, use this as a crutch in moderation. But you can visualize where 135 is. 135 is here. How do you get to that point? was that asking for the sign? Yeah. Okay, so you get there by going horizontally root 2 over 2 and vertically root 2 over 2. So that's the sign, root 2 over 2. Right, but it's asking for the sign, so I'm focusing on that, the y value. Okay, so on the unit circle, this is where 135 is. How do you get there vertically? By going up root 2 over 2. So,
What does that mean? Like, how do you know when you go up to
like, did you see how we did all these? Maybe you and I let's get together at some point and we can like go over it a little bit more. Let's do. Did you have a question? Okay, so 7 pi over 3, right? Where is 7 pi over 3? In which quadrant is it? Discrepancies. Which one? Second, third.
It's in the third one. It's in the first.
It goes around. It goes around.
But then it's 1 pi and 2 pi over 3. It's basically
It's 2 and 1/3 pi.
Okay, so it's 2 1/3 pi, right? So it is going to be in the first quadrant. So in the first quadrant here, pi over 3, right? So this is one of the pi over 3's, right? So that means I go over, do I go horizontally the short or the long length? Short, and I go up the long length. So this is going to be 1/2 because it's the cosine. Okay? All right. So tangent of 5 pi over 6. So first of all, let's do this for a minute. What is the reference angle for this? In radian. For 5 pi over 6. Reference angle is pi over 6. So this is going to be the same as tangent of pi over 6. Hang on. Let me do it easier for you. Okay, so where is 5 pi over 6?
Third quadrant.
Oh, second or third? Second. Okay, so 5 pi over 6, this is 5/6 of a pi. It's just short of a pi, so it's got to be in the second quadrant. Now, I want the tangent, which is opposite over adjacent, y over x. So for this one, is that vertical side going to be the 1/2 or the root 3 over 2? 1/2 over root 3 over 2. How much is that? They're both negative, so they cancel. So it's going to be 1 over root 3. Huh? Oh, no. Sorry. Only one of them is negative. Sorry. I'm sorry. Okay, so it's negative 1 over root 3. Okay, cotangent of 5 pi over 3. Oh. Okay, so here's a little background on that. In my pre-calculus and in our pre-calculus and like, so after this level of algebra 2, we no longer require students to rationalize the denominator. And so sometimes I forget what class I'm in, so I forget to rationalize the denominator. But could you believe there's going to be a time where that's going to be okay to write? Yeah.
Isn't it root 3 over 2 over 1? Or negative root 3 over 2 over 1?
So the 2's cancel out. This is going to be negative 1/2 times 2 over root 3.
Doesn't it go over negative root 3 over 2 and then go up 1/2?
Yes.
So the y is only 1/2. So it's y over.
Oh, it's opposite over. Sorry.
Yeah.
It's
Okay.
opposite over adjacent.
So cotangent of 5 pi over 3. So 5 pi over 3 is 1 2/3 pi. It's in the third quadrant. Third quadrant here. Okay? So, I meant the fourth quadrant. Sorry. I'm trying to rush here. Okay, hang on. I don't know. I'm trying. I don't know why I'm like. Okay, I'm trying. I need to go back into my Zen spot. Okay, so this is 1 2/3 pi, correct? So 1 2/3 pi is here. But also, you have to have these memorized now, where the pi over 3's are 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So 5 pi over 3 is definitely in this quadrant. Now, to go here, I go horizontally 1/2, vertically negative root 3 over 2. So this is going to be negative root 3 over 2 divided by 1/2. Okay, so hang on. So now, lots of ways to do this. If you have identical denominators on the top and bottom, by the way, a shortcut is the denominators can cancel. So now you have negative root 3. Yep. Oh my God, it's cotangent. What is wrong with me today? Yes, I'm so sorry, guys. Okay, I think I need a minute here. Okay, hang on. Okay, hang on. Pause. Focus. Okay, secant of 120. 120 is here. Okay? Now, to go there, I need to go horizontally negative 1/2, vertically root 3 over 2. So the cosine is negative 1/2, right? But the secant is going to be the opposite of that, negative 2. Okay? All right, next one. Cosecant of negative 3 pi over 4. Now I'm going in the negative direction. Negative 3 pi over 4 is going to be here. Right? Well, this is the pi over 4s because, remember, this is negative 3 pi over 4. We're going in the negative direction. The pi over 4s are the 45 degrees. So I go horizontally root 2 over 2, vertically root 2 over 2. Because this is the reciprocal, right? It's going to be the reciprocal of root 2 over 2. So it's like negative 1 over root 2 over 2, which is just root 2. Okay. Okay, so how did we get root 2 over 2? How did we get root 2 over 2? It used to be 1 over root 2, right? That got us root 2 over 2. Remember that way before? And so if I'm going to take the reciprocal of this, I can just take the reciprocal of that, and it's root 2. If you want to go the long way and rationalize, the 2's cancel. It's like this magical thing. Okay? All right, cosine of 480. So 480 minus 360, because we're going to go over the, one circle. It's going to be 120. So how do I, okay, so now let's see if we can just like visualize this, right? How do I get to 120? I have to go horizontally 1/2, negative, up root 3 over 2. So what is this asking us? For the cosine, I have to go horizontally negative 1/2, so that's what I get. Okay? All right. So here I have sine of negative 3 pi over 4. Oh, look, we just did the cosecant, right? Negative 3 pi over 4 is here, so what's the sine going to be? Negative 1 over root 2, which is negative root 2 over 2. Okay. Who had a question before? Yep.
So cosecant is, it's 1 over root 2, right?
Cosecant is 1 over the sine. Okay? The sine of that is 1 over root 2. Sine is 1 over root 2. That means the cosecant is the reciprocal, which is root 2 over 1.
Root 2. Okay.
Okay?
So then, just becomes negative. Okay. And the sine is negative. Okay.
Okay. So here, tangent of 690. How much is that going to be? What's the remnant?
It's 30.
Huh?
It's 30.
Wait, hang on. Raise your hand. Grayson, what were you saying?
Never mind, I think I'm wrong.
No, say it. I think you were not.
Negative 1/2.
Yes. That's exactly it, right? What was the angle? Once you subtract 360, you get 330. Right? At 330, right? We're looking for the tangent, so it's root 3 over 2. Negative 1/2 over root 3 over 2. Okay, so look. I have a fraction over a fraction. When the denominators are identical, you can cancel them. But now look at what we have. This was my main fraction. What do I have left in the top? Just negative 1. What do I have left in the entire denominator? Just root 3. So this will be, you know, when you rationalize, negative root 3 over 3. This is another way of doing it. Now, what if this is not your cup of tea and you're like, you know what, just leave me my times the reciprocal? Knock yourself out. Just get the right answer. Yeah.
I don't get how you got negative 1/2 and 3 over 2. Because wouldn't the coordinate just be 1.0 and then
So it's 330 degrees, right?
Oh.
Not 360 degrees, 330 degrees. Okay, 17 pi over 3 is how much? Huh? Let
2 pi over 3.
It's 120.
Okay, so right. So here's one way of doing it. So this is 5 and 2 pi over 3, right? If you put it in mixed numbers, 5 and 2/3 pi. Right? So look. Let's do this. Look. 2 pi, 4 pi, 5 pi, and another 2/3 pi puts me in the fourth quadrant. But the reference angle is pi over 3 like this. Okay? So I want the cosine. To get to that coordinate, I go over 1/2 down root 3 over 2. So the cosine is going to be, yeah. No, 1/2. 1/2. Okay. So let's graph some of this. Yeah.
So it's the opposite, like cosine means. Oh, no, I got it.
Okay. So let's use data from the unit circle. You know what? I'm just going to draw my own cute little unit circle here, just for this purpose. Notice here what we have, the x values are my angles, but notice they just are the quadrantal angles, all right? So 0 pi over 2 pi, 3 pi over 2, and 2 pi. Let's just put that here. So it's 0, 1/2 pi, pi, 3 pi over 2, and 2 pi. Okay, so let's fill in this table here. When the angle is 0, now this is sine x. Is sine the x or y coordinate here? Y coordinate. So when the angle is 0, what's the sign? 0. When the angle is 0, we're here. What's the y coordinate there? 0. Okay? Okay. Ignore these for a minute. Ignore those for a minute. Okay. Am I pointing to 0 degrees? Yep. On this unit circle, at where my finger is, what's the y coordinate? 0. That's the sign. So 0. Now let's go to pi over 2. Where I'm pointing, what's the y coordinate on the unit circle? 1. Now let's go to pi. What's the y coordinate?
0.
And at 3 pi over 2. And at 2 pi. 1 or 0? 1 or 0? 0. Okay. So now we're going to go from there, from that circle, to this coordinate plane. Oh, wow. So now these are going to be my x values. These are going to be my y values. So when x is 0, y is 0. Pi over 2, which is 1/2 a pi, we're at 1. 0. 1.5 pi is 3 pi over 2, -1, and 2 pi. And don't do anything yet. Don't connect these just yet. How many points do we have? 5. You're always gonna get 5 points. These values on the unit, on the x-axis, we're gonna call these the critical points when we're graphing sine and cosine functions. Always 5 points. Okay, this is the x-axis. Look at what's happening to the points. They're going from the axis to the maximum, back to the axis, to the minimum, and so on. So from the axis, up, back, down, back. It's jumping back and forth around the x-axis. We don't use that term in math. We say the points are oscillating back and forth, right? They're oscillating around the x-axis. That's always what's going to happen. You're always going to be centered around that axis of oscillation, the axis. So now let's go ahead and put a cute little curve here. Not squiggly, this is a sine function, and it's so exciting. Let me tell you how exciting this is. Usually, when I'm going to teach this lesson, I can barely sleep the night before because it's so exciting. And here we are now. So look at that. This is your very first sine function.
These are sine and cosine.
This is just a sine graph. Okay, now, what does it look like? Starts with a W. Oh, wave. It looks like a wave. Okay, now let's do cosine. Again, let's just ignore this stuff here. So let's do cosine. When my angle is 0, what is the cosine or the x value? What is the cosine here? 1. Right, now we're looking at the x coordinate. At pi over 2, what's cosine or the x coordinate? 0. At pi, 3 pi over 2, 0. X is 0 here, and there, 1. So now, let's put these things back. How many points? 5 again. When x is 0, y is 1, then 0, then negative 1, 0, and 1. Okay, again, do you see how the points are pretty much centered around this? They just go 1 away on either side, and that's it. So when I graph this one now, this is again part of a wave. This does not continue. So when you graph this, you're going to graph it as if it really was part of an ongoing wave, right? If you imagine this, this is like an ongoing wave that continues like this. Do you see that? So the part of it that we're drawing, does everybody see this? Right? The part of it that we're drawing is only the middle part when I erase the rest of this stuff. Okay, one last thing. When x was 0 at our starting point, for sine, the y value is on the axis. Here, it's away from the axis. Okay, remember that. Okay. Any questions on this? Hang on, we still have a few minutes. Any questions on this? Okay, so always remember. Okay, so this is what a sine graph looks like. This is what a cosine graph looks like. Sine and cosine graphs, yes, they are waves in every bit that you know it. So if you listen carefully, the music that's coming from downstairs is actually coming to us in the form of a wave just like this, and it's hitting us, right? And so that's what all this is about. Okay, never, ever, ever should your cosine look like a V, because it's not a V. Remember, it's a part of a bigger wave, okay? All right. Any other questions here?